The use of solenoids in valves is perhaps one of the most common applications of solenoids. Take, for example, the simple case of a unidirectional or one-way valve to cut fluid on or off in a system. This solenoid may have a spring retention which causes the plunger to close against the seat of the valve, preventing fluid from passing. When power is applied, the plunger will be pulled back and the valve will open. This valve is called a one-way valve because the flow of fluid is only in one direction. There is one inlet and one outlet, and the fluid goes from the inlet to the outlet. Let us look briefly at a solenoid valve. We know that a solenoid is represented by this symbol, while a valve is represented like this. The solenoid part of the valve is added and represented like this. If the solenoid valve is spring-loaded, the spring will be represented here. As you can see, the arrows show the direction of the flow. The right side of the valve represents the state or direction of the valve when the solenoid is off, while the left section represents the direction of flow in the valve when the solenoid is on. We'll see more very shortly. A solenoid valve is said to have inlets and outlet ports. Inlets can also be called pressure ports because that's where the pressure oil or air of a hydraulic or pneumatic equipment is connected. Some outlets can be called exhaust ports for air or tank for oil, where the release pressure is directed from, for example, a piston cylinder. These exhaust or tank ports can be represented with this symbol. In this valve, when the solenoid is off, the inlet port labeled P is routed to the A outlet, and the B outlet is routed to the exhaust or tank. This action is maintained by the spring, which holds the solenoid valve spool. When the solenoid is energized, the spool allows the inlet port to connect to the B outlet, and the A outlet will connect to the tank. Note that the solenoid pushes the spring. As can be seen in the valve symbol, in the off state, the pressure inlet goes to A and B goes to tank. In the on state, the pressure goes to B and A goes to tank. This valve is said to be a four-way valve because flow takes place in four directions. It is also a two-position valve because the solenoid and the spring combination enable the valve to be in either of two positions. There are two-way, three-way, and four-way valves among the most popular in industrial controls. The term way deals primarily with the number of flow directions the valve can have.
In a lot of cases, manufacturers will provide a four-way valve which could be used as a two-way or as a three-way.
As an example, let's take a two-position, four-way, five-ports valve to operate as a two-way valve controlling air into a system. As a two-way valve, the pressured air is supplied to the inlet port, port 1, and goes to the air system through port 2, while the other three ports are plugged. When the solenoid is off, air is flowing to the system. When the solenoid is on, the air is switched off and blocked. There are two ways, because the inlet 1 can go to the outlet 2, or the inlet 1 can be blocked. Suppose now that we wanted to use this valve as a three-way, in an application which uses an air cylinder whose piston is used to push a bad part off a conveyor, and that the cylinder is returned back to its off position by a spring. If we want to connect it so that air will pass whenever the solenoid gets activated, we would connect it like this. When the solenoid is off, the inlet goes to outlet 2, which is plugged, and the outlet 4 is routed to outlet 5 as an air exhaust where the air inside the cylinder can be released. When the solenoid is energized, the air inlet is redirected to port 4, where the air will push the piston in the cylinder, compress the spring, and push the part off the conveyor. When the solenoid is turned off again, the valve redirects the air inside the cylinder to port 5, and the spring pushes the piston back where the air goes to the exhaust, thus returning the pushing arm. There are three flow directions, one for each way. If the cylinder had required air on the return movement instead of using a spring, we would have used a four-way valve. In this case, when the solenoid is off, the inlet is providing air to outlet 2, which provides air to push the piston back. The outlet 4 is being sent to exhaust outlet 5. When the solenoid is on, the air inlet is routed to outlet 4, thus pushing the cylinder's piston. The outlet 2 is now redirected according to the valve to exhaust port 3. The valves direct flow in four ways. When off, from here to here, and here to here for two ways, and when on, from here to here and here to here for the other two ways to make it four-way. Other valves use two solenoids, which are spring return to center. These operate the spool of the valve, thus allowing another position of the valve where the inlet and exhaust are not directed anywhere and the other outlet ports are closed, making it a centered bypass valve. When solenoid 1 is energized, the other one is not, and the valve connects the inlet to B and A to the exhaust port. When the solenoid 1 is off and 2 is on, the valve switches the inlet to A and B to the exhaust port. The springs return the spool to the center position for both solenoids when they are both off. This valve is a four-way, four-port, three-position valve.